matrix multiplication. So matrix multiplication actually requires that you satisfy a criteria before you even can know if these matrices can multiply. So that criteria is that you put the rows by the columns, which is the dimensions of the first guy, times the rows times the columns, which is the dimensions of the second guy. Okay, if these inside guys match, C1 and R2, if they match, then the dimensions of the resultant matrix will be R1 by C2. If they don't match, then you can't multiply. So it's kind of interesting because now you know that matrix multiplication is not commutative. Okay, that means the order totally matters, and you can only multiply two matrices at a time. So let's investigate these. The dimensions of B is a 2 by 2, 2 rows, 2 columns. The dimensions of C is 2 by 1, 2 rows by 1 column. So I'm going to investigate, can I multiply matrix B times matrix C? So I have to go 2 by 2, and I kind of put it in here so I can see them, times, I put a question mark, 2 by 1. So these inside guys, yep, they match, yes. Therefore, they can be multiplied, and my resultant matrix is going to have the dimensions of a 2 by 1 matrix. Yes. Now I'm going to investigate the multiplication of C by B. So C is 2 by 1. Can it multiply by a 2 by 2? These guys, they don't match. So the answer is no. So it doesn't go both ways because it's not commutative. So now I'm going to investigate. Here's matrix B, which is a 2 by 2. Here's matrix C, which is a 2 by 1. I want to multiply matrix B by matrix C. First, I have to investigate 2 by 2 times 2 by 1. These guys match, yes. So my resultant matrix is going to be a 2 by 1. Then, usually when I have to do matrix multiplication, I do this. The first one, I draw the rows going across, and I use colored pencils or something, and the columns going down. Then I draw the same thing. I go my rows and my columns. And that is what my resultant matrix is going to look like. And I'll show you how we do it. You go to the first one and the first, 2 times 5. Plus, then you move to the second one here and down to the second here. 0 times 4. I'm at the end, That one's all done. This cell is complete. Then I do it again. And I go 3 times 5 plus 1 times 4. Move down. Okay, that is complete. Now I'm just going to do my arithmetic. And I'm going to move this a little bit. There we go. All right, 2 times 5 is 10, plus 0 times 4 is 0, so I just get 10. 3 times 5 is 15, plus 1 times 4 is 4, so that gives me 19. So as you can see, it was a 2 by 1 matrix, just like I thought it was going to be. So now I have matrix A and matrix B. I want to say, can I do A times B? So the dimensions of A are 2 by 2. Can that multiply by 2 by 3? 2 by 3. And yes, these match. So my resultant is going to be a 2 by 3. And let's do it. So I'm going to go rows, columns. Here's my rows, and here's my columns. So I have to extend that a little bit. So now here we go. It's going to go 1 times 3 plus 2 times 0. That's that one. Now this one, I did not leave myself a lot of room. I am still in the top row, but see, I'm in the second column. So it's going to be 1 times 1 plus 2 times 10. And this is going to have to move way over here, okay? So now I'm still in the top row, but the third column, 1 times 6 plus 2 times 1. Okay, that was the whole top. Now I'm going to go down to the bottom row, and I'm back to the first column. 5 times 3 plus 4 times 0. And then back to the beginning of the row again. Next column, 5 times 1 plus 4 times 10. And this is only the second one, okay? The second cell. And then I have to come across to the third column, still in the same row. 5 times 6 plus 4 times 1. Okay, now I'm going to clean this up. And I know I'm going to have 1, 2, 3, 4, 5, 6. So 1, 2, 3, which was my assumption. It was going to be a 2 by 3. So I know I'm good. And there's a lot of checks built into this. So now I'm going to go 1 times 3 is 3 plus 2 times 0, that's 0. So I get 3. 1 times 1 is 1 plus 20, that's 21. 1 times 6 is 6 plus 2 is 8. 5 times 3 is 15 plus 0, that's 15. 5 times 1 is 5 plus 40 is 45. 5 times 6 is 30 plus 4 is 34. Nice. Now, just to show you, I'm also going to investigate B times A. Can I do it? So the dimensions of B were 2 by 3. And the dimensions of A are 2 by 2. These guys don't match, so no, can't do it. I want to determine A squared, and my A matrix is this one. So this is a 2 by 2 matrix. First, I have to investigate. So A squared is A times A. Since it's a square matrix, I know it's going to happen, but I'm going to show you. So 2 by 2 by 2 by 2. And this should be a question mark. Do these guys match? They do, yes. So my resultant matrix is going to be a 2 by 2. So I'm going to do that. So I have 1, 2, 5, 4 times, same one again, 1, 2, 5, 4. I'm going to come in with my colored pencils, rows in the first one, columns in the second. Columns, I'm giving myself more room this time, and rows. I'm going to move up the paper. Okay, so row 1, column 1. 1 times 1 plus 2 times 5. Okay, next, I'm still in the same row. Next column, 1 times 2 plus 2 times 4. Okay, next row, first column again, 5 times 1 plus 4 times 5. Same row, last column, 5 times 2 plus 4 times 4. And now I'm just going to clean this up, do my arithmetic really. Space 1, 2, 3, 4. You see each one of these little cross hatches is going to be one cell. 1 times 1 is 1 plus 10 is 11. 1 times 2 is 2 plus 8 is 10. 5 plus 20 is 25. Let's see, 116. All done. I'm going to do quite a few of these for you because it can be a little complicated. So matrix C, matrix D. Let's just get the dimensions right away. The dimensions on C are 2 by 1, 2 by 1. And on D, it's 1 by 2. Okay, so first I want to do C squared. First I have to investigate. It's going to be a 2 by 1 times, I should use that, a 2 by 1. Look, these don't match. No, it cannot be done. Let's investigate D squared. So that will be a 1 by 2 times a 1 by 2. These insides don't match again. Can't be done. Let's investigate D times C. So the dimensions on D and order totally matters. 6, oops, I was supposed to put the dimensions. So it's 1 by 2 by 2 by 1. Look, these match. So I can do it, and the resultant is going to be a 1 by 1. Let's just do that one right now. So for D times C, I have, I'm going to write it out again. I have 6, -2 times 3, 4. I'm going to come across with my colored pencils. Rows, columns. I always do that. So I'm going to go 6 times 3 is 18 plus -2 times 4 is -8. And that's it. 18 plus -8 is 10. All done. I got a 1 by 1, just like I thought I would. Now I'm going to come down here and I'm going to do C by D, okay? So I'm going to write it again. So to investigate C times D. So C was a 2 by 1 matrix and D was a 1 by 2 matrix. So first investigate. Do these guys match? They do. So my resultant matrix is going to be a 2 by 2. I'm going to write them. So the order changes everything. When we did D times C, we got a 1 by 1 matrix, but C times D is giving us a 2 by 2. So C is 3, 4, and D is 6, ups, no comma, -2. You don't put a comma there, unless you're doing it on the calculator, but we're not doing that today. So since I'm doing C first, I have to do the rows in that one and the columns in this, and that totally matters. Rows, columns. Now I have my places to fill in. So 3 times 6, and I'm done there and I'm done there. But I'm still in the top row because I haven't come over here. So now to the next column. 3 times -2 is -6. Whoops, okay, doesn't matter. Now bottom, 4 times 6, still bottom row, but the last column, 4 times -2. And this is going to give me a 1, 2, 3, 4. Draw out the cells. 3 times 6 is 18. I already did this one. We know it's -6. 4 times 6 is 24. 4 times -2, -8. All done. Thanks for being here.